All right, we've looked at various measurements. We've looked at gram for mass. We've looked at meter for length. We've looked at second for time, Kelvin for temperature. We're now going to see how we can mathematically combine units to make new things that we can measure. This is done all the time, and you're already really familiar with this. I'm just going to talk about it in a way maybe that you've not seen before. So what I'm going to discuss now is called derived units of measure. And the simplest example, I think, to show you this would be area. So we know, like if I have a square, or we'll say a rectangle, we know how to calculate the area of a rectangle. The area of a rectangle, that's going to be the length of the rectangle times its width. So let's say this rectangle has a length of 10 centimeters, and we're going to say that its width, what's that, about, I don't know, 4 centimeters? I'm just eyeballing it here. So if we're going to do this, we're going to calculate the area. I have to take the length, which is 10 centimeters, and then I'm going to multiply it by the width, which is 4 centimeters. And you'll say, well, the area is 40. Well, it's only half right. So if I tell you the area is 40, you don't really know what I'm talking about. The unit that's associated with this 40 is just as important as the number. Just as important. Let me give you an example. Let's say after the first test, everybody comes back and I say, you know, the average on the first exam was a 10. Is that good or bad? Most of you will probably freak out because you'll be thinking of the units associated with that 10. See, that's what I'm trying to get to here. Every measurement in science needs some units associated with it, or it means nothing. So let me say it again. Let's say after the first test, and I come back and I say, you know what, folks? The average on the first test was 10 questions wrong out of 100. Hey, now everybody's happy, aren't they? Because everyone got probably a pretty good score. The average was 90 correct out of 100. So what I'm trying to emphasize here is that it's not just the number that we can feel comfortable writing our answers as, because those numbers only have meaning. They only have physical meaning if there's a unit behind them. You need an explanation. And so by saying the average on an exam was 10 wrong out of 100, that provides context to the numbers. You got to do the same thing here with scientific measurements. Very important. So what is the unit that's associated with this measurement? Is it centimeters? Or is it something else? It's actually something else. The centimeter measurement, that's designated for a length. We're not talking about length. We're talking about area. Now, area comes from mathematical manipulations of length, but it's not a length. They're different things. They're different measurements. You really can't compare length with area. It's like comparing apples and oranges. So what is the unit here? Well, what you do with the units is exactly what you did to the number. So in this case, I took a 10 and multiplied it by a 4 to get the 40. I also need to take a centimeter and multiply it by a centimeter. And when you take a centimeter and you multiply it by another centimeter, you get I could write it like this. I could do that. That's not what we do. But I get 40 centimeters times centimeters. What we normally do is we write 40 centimeters squared. And in this case, where we've finally gotten there, what we've done is I've given you a derived unit of measure. The centimeter squared is a derived unit of measure. It's a unit of measure that comes from mathematical manipulations of your base units. What are your base units? Well, I haven't shown them all to you yet, but your base units are things like the gram, or the second, or the meter. Of course, there's a Kelvin in there too. But a lot of the units that we deal with in science come from mathematical manipulations of these three things here. Often you'll see kilogram. In physics, they often use kilogram, and we'll use that in this course here. But combinations, mathematical combinations of kilogram, meters, and seconds, wow, you get a whole lot of different things that you can measure with that. So here's another derived unit of measure, volume. I'm familiar with that, right? A volume of a rectangular solid. That's going to be the length times the width times the height. We know that. So those are three length units multiplied together. So let's see. I'm not even going to worry about numbers. I'm just going to focus on units at this point. So let's see. An appropriate unit for volume, that could be a meter times a meter times a meter, which would be a meter cubed. That's an appropriate an appropriate unit for volume. We could also do a centimeter times a centimeter times a centimeter. That'd be a centimeter cubed. I think you get the point here. This equation for volume is reserved for rectangular solids, so that's things that are straight on each edge. There are also other volumes that you should be aware of. The volume of a sphere, you might remember that's 4/3 pi r cubed. I almost put squared there. That would be, let's just draw a sphere there. So let's see. And then for a cylinder, let's write sphere here. The volume for a cylinder, that's going to be 4 pi r squared times the height. So in this case, by the way, r is the radius of the sphere. For the cylinder, you have a circle with radius r, and you've got a height h. You should recognize that you should know how to use these particular equations that you've seen before in your mathematics classes. But volume, that's going to be measured in units of length cubed. Length cubed. The centimeter cubed unit, that would be, boy, it's going to be kind of tiny. I'm going to draw a box that's about a centimeter on each side. So if we can imagine, well, that's actually probably too big, but if we can imagine a cube that's 1 centimeter on each side, its volume would be 1 centimeter times 1 centimeter times 1 centimeter. That's the same thing as 1 centimeter cubed. There's also, this is reserved for units of solid volume, but you should recognize there's also units of liquid volume. And what's interesting about the centimeter cubed is it allows us a connection between solid volume and liquid volume in the following way. It turns out that 1 centimeter cubed, that's the same thing as 1 milliliter. Now this usually is reserved for fluid volumes. The liter is a fluid volume measurement. This is also the same thing as 1 cc. You'll sometimes hear people in the medical profession use this term, a cc. cc is just short for cubic centimeter. And so all of these actually can be used as, they're interchangeable. And it's important that you remember this. This one's really important. And things get a little tricky with what I'm talking about right now. And I'd actually like to take some time and go over this, because you can really get fooled with converting between volumes. So let me give you an example here. Let's try this. Try not to get fooled on this problem. I want you to take 100 centimeters squared and tell me how many meters squared that is. Take a little time and try it. Okay. some of you probably mess this up. So let me draw my chart along here. So I'm going to write base. I'm not going to do the whole thing. Let's see, it would be deci, centi, milli. This is really the only portion of the chart that I need to do this particular problem. And if you're, let's see, I'm going to do this wrong here. Let's see, I'm going to put centi here, 100 centi, and I want to move to milli. So if you did that, you're not correct. You got fooled. Some of you did this, and you're still thinking, okay, we're just going to have to fix some things. See, if you wrote 1 in here, then you probably put your 100 in the centi space, and you move to the base, which is your meter space. You move 2 spaces in this direction. So you move your decimal 2 spaces in this direction, and you got 1. Here's the problem with this type of thinking, though, which is good. You're not horribly wrong. You're just partially wrong. I'm going to expand this unit. And see, what's going on here is if you moved this centi to this meter, you only converted one of the 2 centimeters that are here into a meter. Just one of them, not the other one. You got to do them both. So to do this appropriately, if I would take try to back this up so we can see it a little more clearly. I'm just going to draw it just a little bit bigger. Base, deci, centi. All right. So I've got 100 centimeters squared. And I want to move this to, meter belongs here, to meter squared. I'm going to take this here and I'm going to move 2 spaces in this direction. So I do that, 1, 2. And when I've done that, I've converted 1 centimeter into a meter. So I get rid of that right there. So really, as goofy as it sounds, 100 centimeters squared, that's going to be the same thing as 1 meter times a centimeter. Nobody talks about that unit, but that's what you've done at this point. You've only converted one of these into a meter. Let's do the next one. Let's see, I've got 1. And now I've got to convert the 2nd centimeter into a meter, so I move this 2 more spaces. 1, 2, and of course I put zeros in the empty spaces. And so I get 0.001. Now I've converted the 2nd into a meter, so 0.001 meters squared, that's the same thing as 100 centimeters squared. Let me show you this geometrically for what I'm talking about. Once again, I want you to convert 100 centimeters squared into meters squared. And I can take my ruler here and I can draw a line, and a line like this. There we go. So I've just drawn a square that's 10 centimeters on this side and 10 centimeters on this side. Now watch. The area of this is 10 centimeters times 10 centimeters. That's 100 centimeters squared, correct? 10 centimeters times 10 centimeters is 100 centimeters squared, which is this. Now, if I only change one of these into a meter, that's like only changing one side. What is 10 centimeters? Well, that's 0.1 meters, isn't it? You see that? I've only changed one of the sides. I got to do both of them. So geometrically here, it may be easier for you to see why you need to do the conversion twice when you have a square unit like this. If I convert that 2nd, I also got to convert this to 0.1 meter. And so then I see the area here is going to be 0.1 meter times 0.1 meter, which is 0.01 meters squared. So 100 centimeters squared is the same thing as 0.01 meters squared. It's definitely something you're going to have to keep in mind when you're doing these types of conversions. So now, I want you to try this. we're going to bump up the level of complexity on you. Let's say I have something that is, we'll say 1,000 centimeters cubed. Oh boy. How many meters cubed is that? Why don't you try that problem? Well, we said 10. You messed up again. Let's try this. Make sure I got to convert all 3 centimeters into a meter. There's that. Okay. So I'm putting 1,000 in the centi space, but I'm going to remember that I'm going to need to move each centi, all 3 of them, from centi to the base. So let's see. I'm going to move how many spaces? Let's see. 2 spaces in this direction every time I want to convert a centimeter into a meter. So let's see, that's for the first one. That's my first meter. That's my second one. That's my third one. So 1,000 centimeters squared is the same thing as 0.001 meter cubed. Something to keep in mind. Those are definitely problems that you're going to want to make sure that you understand so they don't mess you up later. All right? I'm going to go back to this equation. 1 centimeter cubed is the same thing as 1 milliliter is the same thing as 1 cc. Where does the liter belong in this discussion? Where does the liter belong in this discussion? Well, the liter, that's going to be a base unit. You can treat the liter as a base unit. For example, let's say I have 1,000 centimeters cubed, and I want to know how many kiloliters that is. Nobody uses kiloliter, but I'm just using it for demonstration purposes here, so you can get an idea of what's going on with liter in terms of how to do conversions. Well, I'm going to need this portion of the chart, so I better put my deca unit here, and my hecto here, and my kilo here. Because of this equation, where I know that 1,000 centimeters cubed, 1 centimeter cubed is the same thing as 1 milliliter, I can just immediately write 1,000 centimeters cubed, that's the same thing as 1,000 mils. They're identical. And now, once I've converted into the liter unit, I can do the conversions without having to worry about, doing them 2 and 3 and 4 times. So in this case, I can take 1,000 mils, place it in the milli space, and if I want to figure out how many kiloliters that is, well, let's see, I'm going to need to move my decimal 1, 2, 3, 4, 5, 6 spaces in this direction. And so I'll do that. Try to do it in a way that's kind of big here. 1,000. There's my decimal. I got to move it 6 spaces this way to get me to kilo. 1, 2, 3, 4, 5, 6. 2 empty spaces. So 0.001 kiloliter. That's the same thing as 1,000 milliliters. And 1,000 milliliters is the same thing as a liter. I think hopefully you can see that, right? 1, 2, 3 spaces in this direction. 1, 2, 3 spaces in this direction. 1 liter and 1,000 milliliters. Those are going to be the same thing.